Welcome back to this session. So today in this session we'll be solving some more numericals for overhanging beam and find a shear force and bending moment diagram. So let us start with the first numerical. Draw shear force and bending moment for an overhanging beam as shown in the figure given below. So for this first numerical, the diagram of the overhanging beam is given along with the loading and the length of the beam. So let us see how we can find shear force and bending moment diagram for this overhanging beam. Let's get started. Find its reaction. So for this, there will be reaction at A because there is support at A, so we'll have reaction at A, and there is support at B, we'll have reaction at B. Okay, so RA plus RB will be equal to total load on the beam. Total load on the beam we have 8 kN per meter load acting for a distance of 7 meter. 2 plus 3 5 plus 2 7, so 7 meter plus 5 kN point load plus another 5 kN point load at point C. So this will give you RA plus RB will be coming equal to 66 kilonewton. Now summation of moment about A equals to 0. I'm keeping the reference point here A, so RA into 0. Now this load 8 kN per meter load will going in a clockwise direction. 5 kN load will be going in a clockwise direction. RA will be going in a anti-clockwise direction, and this 5 kN load will be going in a clockwise direction. So clockwise is positive, so plus 8 into the total distance is 7 into 7 by 2 plus 5 into of D से A तक distance is 2. Next I have RB. So RB is going in anti-clockwise, so minus RB into the distance is RB से लेकर A तक distance is 3 plus 5. 3 plus 2, 5 meter. Right, next I have 5 kN load at point C going in a clockwise direction, so plus 5 into total distance 7. This will be coming equal to 0. So 8 into 7 into 7.2 will 7 by 2 will be 196 plus 5 into 2 10 and 5 into 7 35 equal to, I'm sending this minus RB to right hand side, so it will be 5 RB. So if you add up all of this, you will be getting equal to 241 equals to 5 RB. So from here RB will be equal to 241 divided by 5, it will become equal to 48.2 kilonewton. Now from here RA will be equal to 66 minus 48.2, which will be coming equal to 17.8 kilonewton. So we have RA equals to 17.8 kilonewton, RB equals to 48.2 kilonewton. Okay, now let us find the shear force calculation. So shear force calculation. So force at A point P, force at A will be equal to RA, which is 17.8 minus the UDL into uska distance, since it's starting at A point, distance will be 0. So this will become equal to 17.8 kilonewton. Force at D and left hand side of D will be equal to 17.8 minus 8 into, now A से लेकर D तक UDL चला है, and the UDL has run for a distance of 2 meter, so 8 into 2. So this will be coming equal to 1.8, I'm sorry, 1.8 kilonewton. Okay, next we have force at D, right hand side of D. Now force at D and to this direction, right hand side, it will be coming equal to, last force that we got is 1.8 minus, now we have exactly 5 kilonewton load acting on top of D, so minus 5 minus we have a 8 kilonewton load which is starting at D point, so 8 into starting at D point, so the distance is 0. 1.8 minus 5 will be equal to minus 3.2 kilonewton. Okay, now force at B and to the left hand side of B, B का लेफ्ट हैंड साइड ये डायरेक्शन पे, सो वहाँ पर लास्ट फोर्स दैट यू गॉट इज 3.2. At B we have a UDL running and it has run for a distance of 3 meters, so minus 8 into 3, so this will be coming equal to minus 27.2 kilonewton. Next we have force at B and to the right hand side of B, so force at B and right hand side of B will be equal to, last force कितना मिला है, minus 27, so minus 27.2. अब B पे we have a reaction RB coming at B point, right? So it will be, it is coming from bottom to top, so it is plus RB, and RB is equals to 48.2 kilonewton, so this will be giving you 21 kilonewton. Okay, now let's find force at C. Force at C, it should come exactly equal to 5 kilonewton, so let's see, last force that we got is 21, so 21. Now B से C तक पहुंचते पे we have a UDL that has run for a distance of 2 meters, so we have minus 8 into 2, so 21 minus 16 will give you exactly 5 kilonewton. So we have exactly 5 kilonewton at point C. Now let's draw the shear force diagram. Okay, so at A point पे कितना आया है, 17.8, so I'll mark it somewhere around here, 17.8. this is 17.8 kilonewton. और D पे, ये point पे, it is decreasing and becoming 1.8, mark it here, 1.8 kilonewton. Let me join it, right? अब D का right hand side, when it is going to right hand side, it is going in negative, so negative 3.2 kilonewton. Join it. Then when it is going in the right hand side, left hand side of B, it is becoming minus 27, so I'll mark it here, minus 27.2 kilonewton. Join this line again, and to the, when it is moving to the right hand side from B, it is going to positive, it is going in positive 21. If this is 17.8, I'll mark 21 somewhere around here, so this is 21 kilonewton. Now join this line, right? Now C, now from this point directly at C, it is becoming 5 kilonewton, so I'll mark somewhere around here 5 kilonewton. Join this point and then this point here, so this here is 5 kilonewton. Okay, so this is positive, negative and positive. So this is your shear force diagram. Okay. Now let's find moment. So for our overhanging beam, moment at A will be equal to moment at C will be equal to 0. A पे simply supported है, C पे it is there is no support there, so it's a free end here in C, so it will be equal to 0. Now moment at B, ये point पे, तो since यहाँ पर B and C is a cantilever, so we'll solve it in a cantilever manner. So this load will go in this direction, clockwise direction, and this UDL will also go in a clockwise direction. So I have -5 into the distance from C to B is 2 meter, to minus UDL 8 into 2 by 2. So from here you will be getting exactly moment equals to 19 minus 19 point, sorry, not 19, it will be coming minus 26 kilonewton meter. Okay, now moment at D point, ये point पे एक find करना है, तो हम will come from A to D. So we have RA going in a clockwise direction and this UDL going in a anti-clockwise direction. So moment at D will be equal to 17.8. A से D तक distance is 2 meter. Then UDL going in a anti-clockwise direction, so minus 8 into 2 by 2. This will be coming equal to 19.6 kilonewton meter. So now let's draw the bending moment diagram. Okay, so moment at D point P, it is coming maximum 19.6. I'll mark it here. And moment at B, it is coming minus 26 kilonewton meter. Here I have 19.6 kilonewton meter. Now it will be a parabolic because we have a UDL acting, so make it a parabola. From here it will be joining like this. Okay, so here it is 0, so I have negative and positive. Okay, so this point is a point where a bending moment is changing its sign from positive to negative. This point is known as a point of contra flexure. Now let us name this point as point E, and let's find this distance x. Right, now how do we find this distance? Moment at E will be equal to 0. Now if I draw a faint line, so I need to find moment at this point, E point, right? So when I move from A to this E point, I have force RA, then UDL, then this point load going in this direction, which is anti-clockwise. So let us see how we can find. It will be RA, which is going in clockwise direction, so 17.8 into distance. अब यहाँ से यहाँ तक का distance हमें नहीं पता, तो we'll keep it as x. So 17.8 into x, then minus UDL 8 into x by 2 minus this point load 5. Now ये point load का जो है, point load सिर्फ इतने distance पे ही act हो रहा है, right? ये point पे मेरा point E है, ये point पे, और ये point load यहाँ पर है, राइट, विच इज़ डी पॉइंट. डी से ई तक जाने के लिए डिस्टेंस सिर्फ इतना है. अगर यहाँ से यहाँ तक डिस्टेंस x है, हमें नहीं पता, तो द डिस्टेंस फ्रॉम हेयर टू हेयर इज 2. नाउ व्हाट विल बी दिस डिस्टेंस? This distance will be equal to x minus 2. So 5 kilonewton load will be acting at a distance of x minus 2. So 5 into x minus 2 will be equal to 0. Now if you solve this, it will be 17.8x minus, cancel this, it will be 4x square minus 5x plus minus 5 into x is minus 5x, minus minus is plus, 5 into 2 10 equals to 0. Now bring all the like terms together. I'll go in the form, अभी यहाँ पर x का square के form से I'll rearrange this equation. So highest square I'll keep it out. So यहाँ पर I have minus 4x square. I'm bringing it out along with its sign, right? So next I have plus 17.8x minus 5x plus 10 equals to 0. Now if you further solve this, you will get minus 4x square plus 17 minus 5 will be giving you exactly 12.8x plus 10 equals to 0. Now this equation, we have to find the value of x. You can find it from the calculator easily, or else you can use this equation as x equals to minus b plus minus b square minus 4ac divided by 2a. If you remember this, ऐसे equation पे हम ये वाला formula use करते हैं. This is a basic mathematics. I hope you remember it. If not, I'll be solving in both the manner. Other way, you can directly find it by putting it in the calculator, the value of all this. So let me solve it in this manner. So here b is this point, right? B is 12.8, a is minus 4, and c is 10. So b is minus 12.8 plus minus root over of, now b square will be 12.8 square minus 4, my a is minus a, so 4a, I have a, right? A is minus a, minus 4 I mean, so minus 4 into c is 10 divided by 2 into a is minus 4. So if you further solve this, you will get minus 12.8 plus minus, if you solve this inside the bracket, you will get 17.99 divided by minus 8. Now if you take this as minus 12.8 plus 17.99 divided by minus 8, you will get x is equal to, you will get minus 0.65 meter. And if you take x equals to minus 12.8, अब यहाँ पर दो साइन है, एक प्लस है एक माइनस है. So first if you plus it, you will get this much, and if you minus it, minus 17.99 divided by minus 9, you will be getting equal to 3.85 meter. Okay, so which value do we take? We will not take minus, we will take the one which is coming in positive. So this x is lying at a distance of 3.85 meter, the point of Contra flexure. So it is lying at 3.85. The other method to solve is in the calculator. I'll show you. So the other way that you can solve is by using a calculator. Now how you can use a calculator? Since you have all the values here, the equation that has formed is minus 4x square plus 12.8x plus 10 equals to 0, right? So let's say how we can solve. You go to mode and then to equation, which is 5, and then what kind of equation it is? ax square plus bx plus c equals to 0, the third one. So press on the third one. What is the value of a? The value of a here is minus 4. So you put minus 4, right? What is the value of b? Value of b is 12.8. Value of c plus 10. So 10. So equal to, the first value that you are getting is 3.849, which is approximately 3.85, which we have got here. The second value, which is positive, x equals to 3.85. So we're getting it here directly. And the next value that you get is minus 0.65. So you have minus 0.65. So minus, we will not take it, we'll take the positive one. So this is the method to solve this equation by using a calculator. Let's solve the second numerical for today's session. A beam is supported and loaded as shown in figure given below. Draw shear force and bending moment diagrams. Determine the position of Contra flexure from left-hand support. So we need to draw a shear force and bending moment diagram for this overhanging beam and also find the point of Contra flexure. So let us get started. Let us solve the last numerical. Let's start by finding its reaction. Reactions will be, I'll have RA here and at B, RB. So RA plus RB will be equal to total load on the beam. So what is the total load? I have 40 point load, 10 kN per meter UDL acting for a span of 5 meter plus 10 kN load. So from here I get RA plus RB will be equal to 100 kN. Now summation of moment about A equals to 0. I'm taking it from this point. Okay, so RA will be into 0. Now this UDL towards A, ये की तरफ कैसे जाएंगे ये? It will go in this direction. 40 kN load will go in this direction, which is clockwise. RB will go in anti-clockwise direction, and this 10 kN load will go in a clockwise direction. So I have plus 40 into distance C से A तक, it is 2.5, plus UDL 10 into acting for a distance of 5 meter into 5 by 2. Then I have RB going in a anti-clockwise direction, so minus RB into 5, then plus 10 into the total distance is 2.5, 2.5, 5 plus 2, 7. 7 equals to 0. Now from here 40 into 2.5 will be 100 plus, if we cancel this, I have 5 into 5, 25. 25 into 5 will be coming 125. So 125 plus 10 into 7 is 70 equals to, I'm sending this minus to the right hand side direction, so I have 5RB. So if you add up all of these values, you will get 295. This is 70 here, equals to 5RB. So RB will be equal to 295 by 5, which will be coming equal to 59 kilonewton. Similarly, from here RA will be equal to 100 minus 59 will be equal to 41 kilonewton. So I have RA equals to 41 kilonewton, RB equals to 59 kilonewton. Okay, now let's find shear force. Number 2, shear force calculation. So force at A will be equal to RA, which is 41 kilonewton, minus UDL 10, इसके ऊपर UDL चल रहा है और उसका डिस्टेंस 0 है, into 0, so it will be equal to 41 kilonewton. Force at C and to the right hand side of C will be equal to 41 minus, अब C तक UDL चला है for a distance of 2.5 meter. The intensity of UDL is 10 and its distance is 2.5. So this will be coming equal to 16 kilonewton. Okay. Similarly, force at C into the right hand side of C. अब ये C का ये side पे जाएंगे, right hand side. So last force that we got is 16, and अब यहाँ से C के ऊपर we have exactly 40 kilonewton load acting, और वो हम right hand side direction पे लेके जाएंगे, तो we have minus 40 और C और B के बीच पे UDL चल रहा है, तो minus 10, तो ये UDL C पे start हुआ है अभी, so into उसका distance 0, so this will be coming equal to minus 24 kilonewton. Okay, now let's find force at B and left hand side of B. अब ये point B point के left hand side ये side पे find करेंगे, तो it will be last force कितना मिला, minus 24, so minus 24 minus, अब B और C के बीच में UDL चला है, and UDL C से चलते B तक पहुँचते उसका it has traveled a distance of 2.5 meter. So I have 10 into 2.5. So this will be giving equal to minus 49 kilonewton. Okay. Now similarly, force at B and to the right hand side of B. ये direction पे कितना होगा? It will be coming equal to minus 49. अब B के right below B there is a support, और वहाँ पर reaction RB आ रहा है, और ये नीचे से ऊपर जा रहा है, तो it is plus 59. So this is coming equal to 10 kilonewton. Now force at C. No, this is a D point. So force at D point, exactly it should come 10 kilonewton. Now last force that we got is 10. Is there any force between B and C, B and D? There is no force acting in between B and D. So the last force that we got is 10 kilonewton, and we have exactly 10 kilonewton load acting on top of D at point D. So let us draw the shear force diagram. Right, A point पे 41 kilonewton, 41 kilonewton. C point पे it is decreasing, so 16 kilonewton. Let's join the line also, 16. Then C point पे जब ये right hand side पे जा रहा है, तो it is decreasing and becoming 24, minus 24, so 24 kilonewton. Let's join it. And B point पे at this point it is becoming minus 49, so minus 49 here. Let's join it. 49 minus 49 kilonewton. And now when it is moving to the right hand side at B point पे, it is becoming positive, so 10 kilonewton. So I have 10 kilonewton here, or D point पे we have exactly 10 kilonewton load acting, so from here to here 10 kilonewton. So this is positive, negative and positive. So this is the shear force diagram. Now let's find bending moment. So number 3, bending moment calculation. So for overhanging beam, this is my A point and this is my B point here and this is D point. So moment at A will be equal to 0, simply supported है, और D पे free end है, so moment at D will be equal to 0. Now let us find moment at C, moment at B. So B and D is acting as a cantilever point, so we will solve it in a cantilever manner. So moment at B will be equal to, I'll come from D to B. So cantilever पे this force 10 kilonewton load towards B will be going in this direction, which is clockwise direction. So I have clockwise in cantilever is minus 10 into distance from D to B is 2 meter. So 2. This is equal to minus 20 kilonewton meter. Right. Now let us find moment at C point. So moment at C point find करने के लिए हम A से जाएंगे. So moment at C will be equal to, अब ये C point तक हमें force लेना है, तो ये first RA जाएंगे, reaction RA, and ये UDL ऐसे जाएंगे C की तरफ. So RA reaction is going in a clockwise direction, positive. So RA कितना मिला था? RA was equals to 41 into distance is 2.5 minus, अब ये 10 kilonewton per meter load will go in a anti-clockwise direction towards C. So minus 10 into 2.5 into 2.5 by 2. This will give moment at C equal to 71.25 kilonewton meter. Okay, so let's draw the bending moment diagram. So moment at B कितना आया था? It is coming, it came minus 20. So I have minus 20 here, B point पे, which is 20 kilonewton meter, and moment at C, this point it came 71.25. So this point is 71.25 kilonewton meter. Now यहाँ पर UDL है तो bending moment will be a parabola. So let's draw a parabolic line. Now from here go down and join at this line. Okay, so from here ये line should come little like this, parabola, and from here it will go to 0 point here. So this is my negative point, this is positive. So this is the bending moment diagram. Okay, now this point here, ये point पे the moment is suddenly changing from positive to negative. So this is a point of Contra flexure, and let us name this point as point E. Okay, now how do we find? We need to find this distance कि कितना distance पे point of Contra flexure occur हो रहा है. So how do we find? We find it by equation moment at E is equals to 0. Right, so how will we find here? We need to come from, if I draw a fringe line again, मैं यहाँ से ऊपर लेके जाती हूँ. Right, तो ये point पे I have point E. I need to find moment at E at this point. So from this A till E, ये distance हमें नहीं पता, तो we have kept it as x here. यहाँ पर ये x, right? तो हम A से ये point तक जब जाते हैं तो हमें पूरा force into distance करके लेके जाना पड़ेगा. So what are the forces that I have? reaction RA, right? So it will go in a clockwise direction, UDL will go in an anti-clockwise direction, and this 40 kilonewton load will go in a anti-clockwise direction towards E point. So let us see RA clockwise direction. So 41 into distance is x minus UDL 10 into x by 2, then a point load minus 40. now point लोड ये पॉइंट से एक्ट हो रहा है, उसका डिस्टेंस सिर्फ यहाँ से यहाँ तक ही है डिस्टेंस। तो इतना डिस्टेंस कितना है हमें नहीं पता, यहाँ से यहाँ तक का डिस्टेंस नहीं पता। सो वी आर अज्यूमिंग फ्रॉम हेयर टू हेयर x, एंड सिंस यहाँ से यहाँ तक का 2.5 मीटर है, तो दिस डिस्टेंस विल बिकम x minus 2.5, right? So it will be 40 into x minus 2.5 equals to 0. Now from here I'll get 41x minus, if I cancel this it will be 5, so 5x square minus 40 into x will be equal to minus 40x minus 40 into minus 2.5 will be plus 100 equals to 0. Now I'll bring the like terms together. I'll arrange it according to its power. So the greatest power we have is square 2. So minus 5x square. I'll take this together plus 41x minus 40x. Okay. Plus 100 equals to 0. Now this will remain as it is. Now 41x minus 40x will be positive x only 1, right? Plus 100 equals to 0. So we will get this. Now from here again, using this formula, x equals to minus b plus minus root over of b square minus 4ac divided by 2a. So from here again I'll get minus 5 is my a, x, since there is only x in front of x I can assume 1, so b will be 1, c will be 100. So let us write b is equals to 1, so minus 1 plus minus root over of b square is 1 square minus 4 into a is minus 5 into c is 100 divided by 2 into minus 5. So from here you will be getting x equals to minus 1 plus minus, if you solve inside this root you will be getting equal to 44.73 divided by 2 into minus 5 will be minus 10. Now if you solve this, यहाँ पर एक प्लस है एक माइनस है, तो अगर आपने x इक्वल्स टू माइनस 1 प्लस 44.73 डिवाइडेड बाय माइनस 10 किया तो यू विल बी गेटिंग दिस वैल्यू इक्वल टू 4.573 meter. You will be getting this value. Next value, if you take x equals to minus 1 minus 44.73 divided by minus 10, you will get minus 4.373 meter. Now one is coming in negative, one is positive, so this negative you will not take, the one which is positive you will take this value. So the point of Contra flexure is lying at a distance of x equals to 4.573 meter. So the other way to solve this is in the calculator. I'll show you. You'll get the same exact value. Since you are using calculator, I recommend you to solve it in that manner and not in this manner. This is quite lengthy. Now here also, if we solve this equation by using a calculator, you go to mode and then press 5 equation, and then it's the third type of equation, number 3, press number 3. Now the value of a is equal to minus 5. What's the value of b? Value of b is 1 only. 1 the value of C is equals to 100. So this will be giving you, first value is coming 4.573, which we have taken here, 4.573, and the next value which comes is minus, which is coming minus 4.373. So if you solve it manually also, you will get this value, but if you solve it in a calculator, it is just, you'll just get the answer in like 2 seconds, or minimum maybe 5 seconds, right? So this is the easiest way out by using a calculator. So I really recommend you to solve this kind of equation using a calculator. And next, to go back, you press mode again and then one computer. So you go back to your original calculator form. So I hope this is clear.